Kids, so we are going to just sort of fly through this unit. This is the glassware I want you to know. We're going to call the pipettes, the micro pipettes, just pipettes. So you can get rid of the micro there. I told you don't worry about wire gauze, safety goggles to gimme, iron ring, utility camp. Yeah, crucible and cover. So the rest of things here, I would expect you to know. The burette, I'm not as worried about right now, but you'll figure that out later. So yeah, let's just cross that off too. You don't need to know what a burette is. Okay, moving on. You'll figure it out later. Study of matter, that's what chemistry is. Matter is anything that takes up space and has mass. My example was the cathedral takes up space and has mass. Matter is anything that has mass and takes up space. Again, mass is a measure of the amount of stuff. It's not the weight. So the difference between mass and weight is weight has to do with gravity. So that's why somebody doesn't weigh the same on a different planet, but mass should be the same. So that should be uh, uniform and has to do with the fact that it's the stuff in something. So a person like I have the same amount of stuff in me, whether I'm on the moon or on Earth. So the fact that weights are different has to do with gravitational pull. Gravity's really pulling down on Earth when compared to like the moon. So because gravity pulls on Earth more than the moon, your weight is more, but the mass should be the same. There's no less stuff in one person versus the other here. So in order to do that, we need to use the units of grams, kilograms, those type of mass units as opposed to pounds. Okay, then we talked about how just as in biology, animals can be divided into vertebrates and invertebrates, we can have the universe divided into matter and energy. And then there's a relationship between these, which is brought about by Einstein, that E equals mc squared. And that is E is the energy and mass is m. So matter, it can go back and forth to energy. Types of energy, this is more of a physics thing. Kinetic, potential, heat, and light. I would expect you to maybe know some of those for your test. Matter, however, can be divided into two things, either a pure substance or a mixture. So if it's not energy, it can be either a pure substance and a mixture. So what are types of pure substance? There are the elements on the periodic table, and then there are compounds. So elements will be single things from the periodic table, things like gold or carbon or copper. Okay, so just single elements. And these things can be either a metal, a metalloid, or a non-metal. We'll get into that some more. Compounds, on the other hand, can be either ionic or covalent. If there is a metal with a non-metal, okay, that would be ionic. If it's a non-metal with a non-metal, that would be covalent. So basically, we'll get into that. Here are the metals. The metals are all in blue. Most of the periodic table is covered in metals. If you ever forget which side is metal, which side is not, you knew some metals before you got here. Nickel, perhaps, copper, zinc, aluminum, gold. Where's gold? Gold, silver. So you should have known some of these before you got here. And they're on the side. If you look on the periodic table, there will be a staircase here. So they're on the side of the staircase together. All the metals are on one side of the staircase. All the non-metals are on the other side of the staircase. So non-metals, the only interesting one is hydrogen kind of belongs over here with the non-metals, but for other reasons it's put with the metals on the periodic table. But with that exception, the green, so the things on this side of the staircase are the non-metals, right? And the things that are blue are the metals, and the things on the staircase, this little Mason-Dixon line that separates the metals from the non-metals, those are metalloids. So I'm not really going to sweat so much about the metalloids, but you definitely need to know metals and non-metals. All right, so getting back to this, mixtures can be either homogeneous, which means they're uniform, or heterogeneous, which means you can see an interface, which is a border. Let's undo that. Can we undo that? Nope, I guess not. I don't know why it doubled my T. Let's just go up here. So interface, which equals a border. Okay, so sand here, you can see the little borders around the rocks and the shells and the little different kinds of rocks. That's why that's a heterogeneous mixture. Homogeneous mixture would be something like a juice that's clear or a metal that is a mixture of metals, but you can't see where one metal starts, like where the zinc starts and the iron ends or whatever. So another example, if you put ice in that juice, now there's something with interfaces. You can see borders, and because of that, that is heterogeneous mixture. All right. So here's the thing. Is something a mixture or a compound? That is dependent upon whether you have multiple elements in it that would make it a compound. So the law of definite proportions say that a chemical compound contains the same elements in exactly the same proportions, regardless of the size or origin of the sample. That is to say, if you have a jug of water or a drop of water, they regardless will hold two hydrogens and one oxygen, H2O. So those little bracelets that people have where they get a drop of water from the top of Mount Everest and a drop of water from the bottom of the deepest ocean, it's still the same water. It's kind of a cool concept that they do that. So this was brought to you by Joseph Proust, a name I will not expect you to know. All right. So when I went to Greece, the beautiful thing about compounds is because I know the periodic table, I could actually read this even though I don't know Greek, right? I could read these chemical compounds because those are the same no matter where you are. All this other stuff I couldn't read, right? I couldn't read that, and I couldn't read this stuff or this stuff, but I could read the chemical compounds. So even back then, they knew what chemical compounds are. Okay, so what does all this mean? I'm going to ask you to differentiate between a pure substance and a mixture. And is it an element or a compound if it's a pure substance? And is it homogeneous or heterogeneous if it's a mixture? So, for example, tomato sauce. Now, is tomato sauce something that comes off the periodic table? No. So, it is not a pure substance. It is a mixture of things. And then tomato sauce, would that be heterogeneous or homogeneous? I know what you're asking. Do I see stuff in it? Are there little pieces of flecks of pepper or leaves of basil and whatnot? The answer I would say is yes. So that would be heterogeneous. All right. So there's not a uniform heterogeneous, I think. All right. Potassium carbonate. If I tell you the word potassium carbonate and I expect you to know that it's a compound, I will give you the chemical formula. And since you see multiple elements in this, that would tell you it's a compound. And what kind of compound is it? Well, it's got a metal and nonmetals, so that would be ionic. All right, so going on to our periodic table, we're dealing with a metal, potassium, and carbon and oxygen. So those are nonmetals. All right, going back to this thing. Nitrogen is just a single element, so that is a pure substance element. Hexane has multiple elements, so that is a compound, pure substance compound. And since carbon and hydrogen are both nonmetals, uh, right? Hydrogen's here and carbon's here, both nonmetals, so that would be covalent compound. All right, gold is just one thing on the periodic table, Au, so that's an element. Brass is a mixture that you need to know is homogeneous. It's just this silly thing that we make you do. All right, so there are some examples. That's what your quiz test will be on, is stuff like that. I'll just throw something out, and you're going to need to tell me what it is and why, basically. So the periodic table is arranged by properties. We have groups that go up and down. Their families are groups. So things going up and down are families. As you can see here, they're named. I don't think I'm going to ask you names right now. Periods run left to right. So periods go this way. We'll do this again when we cover the periodic table. We'll do it again. All right. So elements is what we're going to explore in class with the superheroes. Metals act are like what you would assume metals are. They have luster. They're mostly solid, ductile, malleable. Ductile means that you can pull them into wire. Okay, so ductile has to do with wire. Malleable means you can hammer it. So hammer it flat is malleable. So those are just good vocabulary words for chemistry. Good conductors of heat and electricity. Elements like the nonmetals, they're dull, gases, brittle solids. They're very colorful, actually. I don't know why dull. I actually don't like dull. Why do I always keep it in here? All right. They're not dull. Look at them. Look at them. Telling me this is dull. Gases, brittle solids don't conduct electricity, come in a variety of colors. So remember, there's a staircase on the periodic table. The staircase is the metalloids. Metals are on one side, and nonmetals will be on the other side. All right. So that's that. Ionic versus covalent. So ionic will be a metal versus with a nonmetal. So if you see a compound that has something from this side and something from that side, that is ionic. If they're both from this side, so if they're both from here, that is covalent, two nonmetals. All right. And the last thing I think is that evidence that a chemical change is taking place. If a solid forms, so when you mix two things in a solid forms, that's bubbles actually. This is the solid. So if bubbles form or gas is produced, that's a good indication you had a chemical change or chemical reaction. If a solid forms, what we call a precipitate, then that's an indication that a chemical reaction occurred. If light or energy is released, that's a good indication you had a chemical change. And if color changed or smell changes, really, then that's a chemical change. And that's it. So that's what I'm going to do for this. I hope that was helpful. And I'll talk to you kids later.